Is this thing on? Hey there everyone. Today we're going to do a little experiment together. And if you want to try this at home, I need you to make sure you get your parents to help you out. Or some other adult. You ready? Let's go. So, I have a candle. I'm going to light the candle up. If I wanted to blow out the candle, what could I do? Well, I think the easiest way is for me to just blow it out. But what if I want to do it in a little bit more creative way? Let's take a look. I'm going to add water to my little pan. And add a little bit more. And now I'm going to light the candle. What do you think would happen if I cover the candle with a glass jar? Do you think it'll stay lit? There's only one way to find out. Let's take a look. And I'm not going to use just any jar. I'm going to use a cylinder. It's really long and it's made of glass, and I'm going to turn it over the candle and push it down. Do you see the flame getting smaller? And now it's out. The water went up the tube. Let's take a look at that again. So in this little experiment, there are two interesting things that are happening. The first one is that the candle goes out. We can see that it's not lit anymore, and we can ask the question, well, how come? Well, there's a couple things happening here. We need oxygen to react with the paraffin. That makes the flame. And because we covered the flame, there was no more oxygen that could get in. And so that reaction ended. We depleted or reduced the amount of oxygen, and we increased the amount of carbon dioxide. The second thing that we saw is that the water level went up. How could that be? Well, what's really interesting is the carbon dioxide doesn't take up as much space as the oxygen. So as the oxygen goes down and the level of carbon dioxide goes up, that gas doesn't need as much space. And so the water level goes up. But did you notice the water level doesn't go up all the way until the flame's completely out? There's something else happening there. And that has to do with the temperature of the fire. And when it goes out, the cooling of the air. There's a lot going on here. So in this little experiment, you might now have some more questions. Like, why do we need oxygen for things to burn? How come carbon dioxide doesn't take up as much space as oxygen? What is oxygen? What is carbon dioxide? These are great questions, and I look forward to hearing from you if you have more. For now, that's all for today. We'll see you soon. Anybody know how to shut this thing off?